Year 8 and welcome to your third lesson in data representation, where we're going to be covering hexadecimal code. Today's target is that you're going to be able to convert hexadecimal to denary and binary. The first exercise of today's class is going to be the connect exercise, which is a gap fill. So I'd like you to try your best to fill in these gaps. Let's see what you can figure out. And we'll come back in 5 minutes and we'll go through the answers. Pause the video now. Okay, let's go through the answers. So, hexadecimal, or hex, is a base 16 number system. This means that it represents everything using just 16 digits. The numbers 0 to 9 and the letters A to F. Benefits include making the code a lot simpler, easy to remember, quicker to read, and less susceptible to input errors. Hex can be used to represent anything from numbers to letters, and even error messages. By the end of this lesson, you will be able to describe the hexadecimal table, you'll be able to convert binary to hexadecimal, and convert hexadecimal to binary. Let's move on. So, what is hex? Hexadecimal, also known as base 16 or hex, is a positional numerical system with a base of 16. Each hexadecimal digit represents 4 binary digits. So for example, using the table below and splitting our code into 2 lots of 4, 0001, which would equal 1 following this table, and 1100 is 12, that would equal your C, giving you your 1C. Let's take this further in depth. So, how are you supposed to remember all these numbers? Well, we've got this hexadecimal conversion table here, going from 1 to 15, and then 1 through 9, and then starting on A, B, C, D, E, F. Simple, right? You get to 9, and as soon as you're going into double figures, you just start using A, B, C, D, E, F, up to 15. And we use the hexadecimal table, remembering that numbers go up in 16s. You know, like binary doubles each time. Hexadecimal goes up in 16. For the tests that you'll be doing, eventually at GCSE level, you'll only ever use these two, up to 16, 1 and 16. Let's go through a few examples. Okay, let's go through a worked example. If we wanted to find out what 3A is in denary, first thing we're going to have to do is draw our table. So 1 and then 16. Just like we did in binary. Next, we find out, we put these in here, and then we find out which one represents what number. So, A represents 10. So A is 10. And then we need to times 3 by 16, or 16 by 3. And that will give us 48. Then we add these two numbers together. That gives you the answer. So 3A is equal to 58. Let's work this one out together. So, I hope you've wrote down this table at home. If you haven't, pause the video and write it out now. So we're going to figure out what 2E is in denary. What are the things we've got to remember? Well, we need to remember, follow along, is the 1 and the 16 table. Yeah? And then we need to put this 2 into the 16s, because it's on the left hand side. And then we need to find out what E is in this table. So E is equal to 14.
So we're going to put 14 here. Next thing that I want you to do is times 16 by 2. What does that give you? That's right, 32. And then 1 times 14 gives you your 14. And then adding them together, what do we get? That's right, 46. So the decimal value of 2e is 46. Well done. Now it's your turn to try this independently.
So during today's demonstrator session, you're going to be working out these 6 tasks. Please email me your finished products before we go through the answers. Give yourself 10 minutes, that's fine, and pause the video now. Here are the answers. Well done if you've got all them right. The next thing we're going to do is we're going to go back a step to activate, because we're going to learn how to convert hex to binary. We're going to start off simple. What is 0 as a 4-digit binary number? So 0 as a 4-digit binary number would be 0000. B. What is 1 as a 4-digit binary number? I'll let you work that one out. And then, once you've worked that one out, I'd like you to work out the rest of the binary numbers in the table to the right, where it says hex and binary. So the top one, 0000. Now you've worked out that second one is 0001. And I'll leave you to work out the rest. I'll come back in a moment with the answers. Give you about 5 minutes for this, so pause the video now. So now here you can see the table completed on the right. Let's move on.
Okay, let's go through a worked example taking a hexadecimal number into binary and then into decimal. So we're going to work out what the binary number for 5f is. So 5f. So looking at the table, we know that 5 is 0101. And then we know that f is 1111. So the binary number for 5f is 0101 1111. And then all we have to do is take this into our table to find out the denary number. So this is 64 plus 16 plus 8 plus 4 plus 2 plus 1. And that will equal 95. Let's move on.
Now on to a demonstrate task. Now I'd like you to convert E2 into binary. For about 5 minutes. Pause the video now. So here's the answers. E2 in binary is 11100010. As you can see, I've split them into 2 lots of 4. 4 bits is a nibble. And this is so that we can find them on the table. So E is 1110 and 2 is 0010. Okay, for the final demonstrate exercise, you're going to be converting these denary numbers into hexadecimal. There's an example already set out where we've found the hex for the denary number 43. As you can see, it's broke down into the two nibbles, 0010 equaling your 2 and 1011 equaling your B. Give yourself a good 10 minutes for this. So pause the video now. So here are your answers. Well done if you've got them all right. If not, please correct yourself. I'd like you to email me how many of these you got right, just so that I can check that you're all on track. Let's move on to the consolidate. And for the final task, the consolidate, I would like you to complete the Microsoft Forms quiz by following the link either in your email that you've received or by copying this link into your browser. I'd like to thank you for all the effort that you've put in today, and I'm really glad that you're understanding hexadecimal code. I'll see you in the next lesson. Bye!